Hi, everybody. So we'll just give a minute or two just to give everybody a chance to join after their calendar invites go off. So we'll start at another minute and a half. In the meantime, maybe while we're waiting for people to join, where's everybody joining from today? Use a chat. Cool. Hi, Nate. Anybody else in yet? Nice. Some people close by, some people really far away. Nice. All right. Well, that's about a excuse me. It's about a minute past, so I think maybe we'll just kind of get going here, and people can roll in as they get here. So today is the third in a three-part series of webinars that are aiming to explain how to use Preseem for support-focused use cases. So specifically from customer down to solving problems for a customer versus the network operation side being trying to make the network better for all customers. So Scott did one a few weeks back. Jeremy did one a few weeks back before or after that. And then of course, this one. This one's going to focus specifically on latency, whereas the other ones touched on some more broad aspects of Preseem. I think all three together give a pretty good picture of how you can use Preseem for many really, really interesting and powerful support use cases. So a little bit about agenda. I'm going to do a quick little bit of housekeeping, tiny bit about myself, a little bit, then jump into the meat of the presentation, and then we'll have Q&A at the end. So on the housekeeping side of things, we're going to try to hold the Q&A to the end. I'll pay attention a little bit to the chat, but it's kind of hard to follow all the chats if they really get going during the presentation. So we'll have a Q&A section at the end. There is going to be a poll come up in just a couple minutes just to get a little bit of information on people that are attending the session. And this webinar will be recorded as well. So we'll send out a copy of it afterwards. You can hopefully, if you miss anything, you can catch it, or you can share it with your team and hopefully they'll get some value out of it too. So a tiny little bit about myself. My name is Dan Siemon, co-founder, CPO of Preseem. I've basically worked in internet providers my whole life. From when I kind of grew up in a rural area, didn't have good internet, started an ISP because I wanted internet, and I've basically worked with ISPs ever since. That's been quite a while now, but it's basically been a focus of everything I do, from building products at Preseem, obviously, and other companies as well. So with that, you should see a poll coming up right now. So if you could see that, we'll just take a second and give everybody a minute just to answer that. We'll just get a sense of kind of the people that are on the call and how often they use Preseem for latency information, I guess, for support and network operations use cases. So we're coming in at about 50-50 right now. Interesting. That is surprisingly equal. All right, I'll give a couple more seconds. Anybody else wants to jump in and vote there? Oh, we're starting to get more votes again. Maybe it took a little while for the poll to come up. Yeah, they're coming in now. Cool. So that is not exactly what I expected, actually. I would have expected that the number of people that were using the latency metrics for network operations would be higher. Maybe that is because we've focused this on support specifically, and that's the focus of the people who have joined. But that is not exactly what I expected. So very interesting. Okay, so I'm going to continue on. So before we dive into the meat of this, I just want to kind of do a very brief overview of what Preseem is and what we're trying to do. Ultimately, we're trying to help our customers be successful and grow, help them spot upsell and acquisition opportunities, reduce churn, make customers happier, and generally deliver better experiences. We're focused on helping customer support teams, which is obviously the focus of this particular webinar, to be able to efficiently get to root cause, escalate to the right place if they have to escalate, or know what to do with the customer if it's not a network problem, they don't have to escalate. Helping network operations teams be proactive, get out there, address the network quality problems, deployment problems, capacity problems before they become customer problems, and of course, support the growth aspects of the business. And where we originally started and where we've focused a lot of our initial energy was on the QoE and traffic management side. And what's really cool about this little webinar is we're able to focus a little bit on that again. And in building this, I think I kind of realized that we haven't spent maybe quite as much time talking about the original core features of Preseem lately as we maybe should have. The latency measurements were really one of the very first, and I think one of the most powerful features of Preseem. That combined with the topology information allows us to understand at a really big picture what parts of the network are delivering a good experience, what parts aren't, so you can drive operations and help customers. And since then, like when we first rolled that out, that's obviously been really powerful for understanding the kind of the traffic level of things, like extracting that from traffic. But what it doesn't do is it doesn't answer the root cause of where the problems actually are in the network. And that's why we've spent a lot of time in the last couple of years doing integrations one layer below the traffic, which is the OLTs, the ONTs, the access points, the CPU radios, extracting information from there and combining all that back with the quality of experience to have a more powerful platform to answer customer issues and all of the outcomes that we just talked about there. So it's kind of refreshing in a way to be able to jump back a little bit and focus on something that's kind of near and dear to my heart and a very core feature of Preseem that maybe we don't, again, spend quite as much time talking about these days as we should. So our platform today consists primarily of three main components. So we have our inline device, which measures the quality of experience, ties that back to the topology information, optimizes the packets that are delivered to customers. I'm not going to talk about that part at all really today. And then the polar, which is the second part that I mentioned, that's reaching out to the rest of the access network to extract the information, to combine that, to build subscriber topology, to get OLT stats, AP stats, et cetera. And then we combine that all in the cloud to implement the use cases and workflows and stuff that we're talking about. So let's get into the main point of this session, which is to talk about latency, why it matters, and how you can use it to solve support problems using Preseem. It's interesting to think about latency and how important it is to the customer experience. It's really easy to measure bandwidth, which is why we often market and talk about our internet plans in terms of bandwidth. You run a speed test, you see a number, bigger's presumably better. But what really matters often for the customer experience is actually the latency delivered by the network. So this is obvious maybe in cases like video games or VoIP calls. But what's less obvious is even simple things like web browsing. Like when you go to a web page, there's 30 TCP connections come up, going to a whole bunch of trackers, a whole bunch of images, a whole bunch of HTML pages. And if those don't get rapid responses for things like a DNS lookup to get the end host address or the initial TCP handshake, then the overall experience is going to be bad. So this is, affects social media. It really affects all aspects of the internet and how people perceive the speed of the internet. And this is something that, we spend a lot of time talking about and something we spend a lot of time optimizing as well with the traffic optimization side of Preseem. And of course, the measuring side feeds into that as well. So very important to understand the latency that's delivered to customers and use that as a tool to understand the overall quality, because it's really one of the most predictive things of how people are going to feel the quality, that feel positively or negatively towards the quality of their internet. So let's talk a little bit about the causes of latency. So the most obvious one that you might think of is just how long it takes those bits to move through the network. So if you're in fiber, it's how long the photons take to go down the fiber. Copper, electrons down the copper, for example. This is fundamentally limited by physics. We don't get to make this a lot better. If you do manage to make this a lot better, you're probably not going to be worried about delivering internet anymore because you've solved some pretty fundamental physics problems. But there are some things that some people and organizations will do if they really, really, really care about latency. So they will have really short fiber cables in like a high-speed trading exchange, or use longer wireless links to have less conversions between media, because that's going to have lower latency than we'll talk about in a second of what happens when you buffer packets. So there's things people will do, but really when it comes to residential commercial internet, we're really not worried about propagation delay. Unless you had, I don't know, like you're backhauling through geosynchronous satellite or something like that. You're just really not going to be worried at all about the propagation delay in your network. But what does add latency is buffering. And some amount of buffering is just inherent. It's absolutely necessary in packet networks. And I have a longer version of this presentation that explains all the details of why that is. So I'll skip that right now. But if you take this simple example of a device that has 2 input queues and 1 output queue. You could just think of this more simply as 1 input queue and 1 output queue, like an access point, right? Ethernet in, Wi-Fi out, for a simple example. When a packet comes in, the device is going to read those bits off the wire. It's going to store it in memory. It's going to move it to the output queue, and the output queue is going to transmit it. So write the bits to the wire. That could be immediate if the output interface is idle. But if it's not idle, it has to hold it for a little bit of time. And that buffering, and the extreme version of it, which we'll get to on the next slide, is fundamentally what drives most of the latency on a packet-based network. Again, unless you're crossing continents or geosynchronous satellite or something like that. Again, so very fundamental to how packet networks work, but it does introduce some amount of latency to hold that packet and then decide to send it out the other side. So an extreme example of this is if you kind of using simple numbers that are just kind of easy to reason about. If you have a 1 megabit per second link, 1500 byte packets, it's going to take 12 milliseconds to transfer every one of those packets. So we don't really think about this, that it takes time to write bits to the wire. So if we have a situation where we have a link here at the bottom, it's transmitting the packets off the bottom. And the packet that we really care about, the one that's key to our experience, is that red one on the top. In this overly bad example, that red packet, by the time it is completely written to the network, is going to take 84 milliseconds to write. That's obviously a really, really, really long time. So 1 megabit, small for current plans, but it gives you a sense of how bad this can get. And these examples of having way too much buffering and not managing the queue properly and all that is kind of canonically called buffer bloat. And again, that's something that our traffic optimization techniques aim to optimize away, but we're not really focused on that part today. When you look at like Linux and the operating systems as well, like Linux for a long time had 1,000 deep packet buffer as a default. If you had a 1 megabit link and 1,000 packets, 1,500 byte packets, like that's 12 seconds of latency. If you've ever paired your phone, perhaps you tethered your laptop to your phone and then done a ping and seen really, really crazy times, this is what's happening. Something in the network is holding onto those packets for way, way too long. So again, the experience here of getting those important packets out the other side is very important to the overall experience. So before we go into a little bit of theory of how we can use latency to understand network problems, let's talk about how we measure latency with Preseem, because it's really important to understand this. So what we have is we have an inline device that sees all the traffic. That's the blue box here at the top. And then I've got a simple network here, which is router backhaul, OLT, ONT, Wi-Fi. Could be access points, could be whatever. It's just simple network. So if we imagine a customer has just requested google.com, there's a bunch of TCP segments coming back from the internet, heading toward carrying data towards that subscriber. So here we have one TCP segment. When we see that, we record the sequence number of that segment, and we record a timestamp. That packet then moves through the network. It gets to the end device. And this is really, really key to some of the stuff we're going to talk about later. This isn't to the ISP mark. This is the device in the home. This could be, my phone. This could be the TV in the garage, 200 meters out back, or it could be a PC directly connected to the ONT in this particular example. But the key thing is that actually we're measuring the round trip all the way to the device, which gives us visibility into the experience in the home as well. Once that device receives that segment, it's going to send an acknowledgement back. That acknowledgement is going to flow back through the network. Once it reaches Preseem, we see that acknowledgement. We basically look at the current time, subtract the old time, and as the orange thing indicates there, we're able to calculate the latency for that particular round trip through the network. And we do this at very high rate, like basically 1 sample per round trip for all the TCP flows, and roll that up into individual subscribers and tie that into the topology. I'll get to the topology again in a second. But again, the really key thing here is we are measuring that latency because it's the end device that's acting. We are actually getting visibility into the home. It's also important to note that this isn't exactly the same as like ping latency. Like if you were to ping the Wi-Fi device here, you're going to get a much lower number because there's other things that are intrinsically part of TCP, like when it acts and when it doesn't act. But this turns out to be very, very highly predictive of the experience, and in part because TCP is important to the experience. Lastly, we also tie this to the topology. And this is what we're going to get into in the next couple slides, that because we understand the network topology, we're able to take an individual sample, map it to a path through the network, and then use that information from the different paths to deduce where the problem is in the network. So that's the examples I'm going to go through here. So this looks a little complicated, but it's not too bad, I hope. So let me just explain what this is. Very simple network here, again, with Preseem somewhere near the core of the network, a couple of routers on a path to a site that has an access point with a couple subscribers. That's up in the top right-hand corner there, and an OLT with one subscriber. So obviously in a real network, you're going to have lots of subscribers. You're going to have many APs. This is super simplified just to fit on a slide. I've labeled every individual link here with a letter, just so we can talk about it. And then the gray bar underneath, I'm going to color as we move through with the quality of experience of that link as it's measured by Preseem. Okay. And we'll go through an example of how we can deduce where the problems are in the network, leveraging Preseem's TCP latency measurements. So this first example, we have every single link in the network is bad. So remember, the way we explain the TCP latency measurement is we're measuring from the box. We do actually, in the newer software, measure cloud side too. We don't expose it in the UI right now. But we measure from the box down to the individual devices, okay? And then we map it to the topology. So here we see that every customer in the network has a poor experience. Every customer in this very obviously simplified network. So just to make that a little bit more obvious, the path from A to E is bad. The path from A to J is bad. And the path from A to G is bad. So if you look at this, you can, especially when you get a lot of subscribers, three's obviously oversimplified example, but you can start to get a picture of where the likely problem is. What is the commonality across all those subscribers? And it's obviously one of those two links at A and B. So we can deduce from this that one of those backhaul links is likely congested, because if there was any subscriber that wasn't having a bad experience, it couldn't be those links, which we'll get to in a second. So again, at the end, we're going to go through a couple of Preseem examples specifically. These ones are just meant to be a little bit more abstract to kind of demonstrate the concept. Here's another example. So here we have A and B are good, HIJ are good, and basically everything on the access point has a poor quality of experience. Again, that's those red bars. Okay. So to draw out the paths, we got good quality of experience across that path. We got bad quality of experience across DE there at the top. We got good quality of experience at the bottom from A, B through to J. And we have poor quality of experience at F and G. So think about this, how we could deduce this. So if the customers in the OLT at the bottom, it doesn't have to be fiber, it could have been an access point there too. If those customers there are getting a good experience, the problem can't be the backhauls, because they would be driving all of the latency up across all the paths. So we can rule out the backhauls. Also, if we look at the up in the corner there, we see that all the subscribers have a high latency, poor experience on that access point, which is a very, very strong indication that the problem here is the access point. Again, just kind of deduction, if there was even one subscriber that did not have poor experience, then the problem is not the access point. But when they all do, it probably is the access point. So last kind of abstract example here. This case, we've got a subscriber at the bottom on the access point that does have a good experience. So specifically the example that I just gave a second ago, where we can see the experience through the fiber network is good. The experience through one customer is good, but the measurement of the latency and experience for that individual customer at the top, that first one, is bad. So this directly points to a problem with that subscriber. So as a support rep, I don't need to look at the access point, probably. That's not likely where the problem is, because there's other customers that have good experience there. So this could be a problem with the link to in this case, it's a CPU radio and an access point, but specifically it's a problem with the link with the customer, or possibly in the home. And we'll talk in the next few slides about how we can distinguish those two use cases. Okay, so that's just kind of an abstract way to think about how we can leverage latency tied with topology. And it's really the QoE metrics. We have a bunch of QoE metrics, right? We have there's another metrics as well, throughput, TCP retransmissions, other things like that. I'm just entirely focused on latency right now, but having metrics tied to topology allows you to deduce things like this very easily. So as I said, the problem is likely specific to that one customer because they're the only one that's experiencing poor QoE or high latency. So we leverage latency all over the place in Preseem. It really is one of our core metrics. That top little chart at the top of showing the access point latencies over time is kind of one where I guess people have shared for many, many years. It's a very early chart that we developed. We have kind of a latency score you can see in the bottom left corner. We can look at latency on a per access point basis, per CPE radio, or sorry, per IP basis, per subscriber basis. And more recently, we've started exposing a little bit more distribution information as well. So the chart in the bottom corner, which I won't spend too much time on right now, because this is meant to be a short webinar, it shows that distribution where you can think of the 5th percentile as kind of the best case latency, the 80th percentile is typical, and the 95th percentile as a worst case. We'll just take kind of oversimplification there. And this is really interesting because it means that you can use it to deduce if there's any congestion anywhere upstream. Because if there's congestion upstream, that 5th percentile, that best case, is going to go up. If there's not, then it's unlikely to go up. In this case, you can see it's pretty flat. So I'm not going to go into too much detail there, but you can really determine a lot of really interesting things about the network just by looking at the latency, or really any metric, once you can tie it to topology. It's the topology that makes it actionable, that you can identify where to focus your efforts. So let's go through a quick example of how to do this inside Preseem. So I've just grabbed a few little snippets of the UI. I think it's a little bit easier to see than trying to use the full screen. So we'll see how this goes. I haven't tried to do this before. So in this case, we have a customer called Bob Smith who's called in to say his internet's not good. Unhappy, his game doesn't work, his kids complain about buffering, whatever those things are. In this case, as a support rep, you search for Bob Smith. You use Preseem's global search, which is going to take you directly to that customer service and where it is attached into the network. And in this case, again, because we're focusing on latency, I'm only going to show the latency chart. And we can see here that this customer has pretty poor QoE and latency specifically. Every night, almost every night, it's maxing out at the top, and it's very, very high. So there's a really good chance this customer has a real reason to complain. And it probably is not related to their home. So they probably are telling you something real here that needs to be investigated. Inside Preseem, you can then use our topology information to quickly get to the element that services this. So we spend a lot of time building out a network topology and understanding which subscribers are where. That's a big part of what we do today. And this works across all the vendors. So OLT vendors, access point vendors, you don't have to jump to other tools. You can just look at the topology picker at the top and jump to the device that's serving this customer. So in this case, I'm going to jump to an AP. So this is the example I picked earlier instead of an OLT, but let's use that. And if I jump over to that AP, I can see that this whole AP has bad latency and delivers a poor experience. Like Preseem is calling it out that this AP is in bad shape. So if I'm a support rep using this, I can look at this and think, okay, it's not worth my time right now to spend a lot of time helping the customer debug their in-home Wi-Fi. Like there's something going on the network side. You've identified the likely root cause, can either try to address it or escalate to network operations or whatever your internal process is. But you can give the customer an answer and not just spend an hour on the phone trying random things and see what's going to happen. I mean, that doesn't lead to a productive support team. And it doesn't lead to a happy customer who's on the call, not actually accomplishing anything. One more example, another person. This is Sally Jones. So Sally calls in, says the same thing. My internet's not good. Kids are unhappy. I can't play Fortnite, or like my kid plays Fortnite all the time. Can't play Fortnite anymore. So we search for that subscriber. We can jump over to their service. And again, we see they're not wrong. Like there's some quality problems here. Especially in the last 24 hours. It looks like there's a period for a few days when it wasn't terrible, but it was really high before. So they likely have a legit complaint here. This is something that we should investigate and not just kind of, assume that it's a problem with the customer's in-home Wi-Fi or some other thing. Again, we can use this topology information that we have inside Preseem that we build and maintain automatically to jump over to that access point. Again, whether it's a Cambium, a Tarana, Ubiquity, Calyx OLT, Adtran OLT, all those things, you can just jump over to it. Again, here we just have a simple example of an access point because it was easy to get. So I click on that access point, I jump over there, and here we have the exact opposite situation of what I talked about earlier, where we have an access point that's in great shape. This access point is nice, low latency all the time. We're saying it's in that little Preseem blue, which is the good, healthy place. You don't see it getting high on individual days. So as a support rep, I can look at this and say, okay, the access point is not overloaded, almost certainly, but this customer is having a bad experience. So this has to be either a problem between the access point and the CPU radio. So maybe a tree grew in the way, an antenna got blown out of alignment, any of the million things that go bad, or it's a problem in the home. And this is really where that other layer that I mentioned that we've built comes key, because with this information alone, you can't determine if it's a problem in the home or in the fixed wireless network in this particular example. Same thing for fiber. To do that, you really need to have the information that comes from that access network equipment itself. So one slide forward here, this is where that layer really plays. So we can use that same topology picker to click on the CPE radio for that individual subscriber. And again, just using, it doesn't matter what vendor it is, it's a single click. You're not jumping over to other systems and trying to understand how their metrics work. If we jump to this one CPE radio, we can see immediately that Preseem is throwing up all kinds of warnings, like poor RF performance, low link rate, high RX airtime usage. We're basically saying here that almost certainly the problem in this case is between the access point and the CPU radio. So again, if you're L1 rep, like support rep working with a customer, you can escalate to the appropriate place. You could have a truck roll sent if you think it's an antenna alignment, whatever those internal workflows are. But there's no point keeping that customer on the phone for an hour and trying to muck around with their in-home Wi-Fi. Because even if that is a problem, this problem is going to get in the way first. So those are a few examples of how you can, I guess, what latency is, how you can use it to operationalize support experience, and hopefully get to that root cause faster, both so that you can escalate to the right place and have happier customers, not just spending on time on the phone, trying things because there's no visibility to actually really understand what's going on. And lastly, these are meant to be short webinars, so hopefully this is short enough. Lastly, quick little sneak peek that as I went through that algorithm of kind of deducing where the problem was in the network, you might wonder, well, is it actually possible just to do that automatically? And that's exactly what we're working on right now. So this is a mock-up from one of the prototypes, so it's not exactly how things will look. But the team right now is working on building this where when you go to an individual customer service, if the AP latency is high, or it's a suspected in-home Wi-Fi problem, or it's a suspected problem between the AP and the CPE radio, for example. I mean, so that one gets mixed up with Wi-Fi just by the nature of things. But we're able to point out directly with a diagnostic. And really the goal here is to make it as quickly as possible for your support reps to know where the problem is. And again, escalate or help the customer and make them happy. So hopefully that was useful overview of why latency is important, how we measure it, how you can use it to find problems in the network, specifically with like specific parts of the network, and then a little bit of how you can do that in Preseem. So with that, we'll open it up to any questions. And I do not see any questions yet. Does anyone have any questions? None? All of that was super obvious? Diagnostics. So the diagnostics are part of the advanced fixed wireless tier. So they are available on CPE radios and access points today. They will be all available on services when we roll out this next thing that I just showed the little sneak peek of. So yeah, if you want to just reach out, like if you go into Preseem, go to the chat and just start a chat, and we can somebody can help you explain what those are and how you can get them if you're interested, or maybe they're already there and they're just not in the place that you're looking. But if you go to access point and CPE radios, you should see them. Thanks. Thanks, Nathan. Glad it was useful. All right. Last call for any more questions. So Dirk, still a bit confused as to what look for when looking at the 80th and 95th. So this is something that we need to do a little better job on the help for, I think. So let me just get back to there. So what this is aiming to do is it shows a distribution of the latency samples, which percentiles sound more confusing than this really is. You can just think about the best case. So the 5th percentile is the best 5%, like the lowest 5% of samples. So if you see that staying very flat, then something upstream is not raising the latency for everything. Because if it was raising the latency for everything, then even the best samples would start to go up. So this example here in the bottom right corner, there's a little bit of that. Like you can see, I don't know exactly what happened here on the before 6 a.m. in this particular time window. Like it went up a little bit, but it stayed pretty constant. So you can be pretty confident, like this happens to be an access point, that there's no problems upstream of that access point. We have seen other examples where that whole fifth percentile shifts up through the night, and that is a very clear indication of a backhaul problem. So that, but yeah, we need to do a little bit better on the help and the explanations of what to do with that, because it's distributions, percentile. It sounds very mathy, and I think we can do a better job there. Yes, all of the webinars, all three of any webinar we do, we always make public. But these three that were focused on support-based use cases, yeah, we'll send out some links to them as like a kind of a series. They do overlap a little bit, but I think they all align pretty well and how you accomplish support use cases in Preseem. How do you get the latency meter in the bottom left corner? So the chart here that says the 129.99, that is likely on an access point. So if you go to an access point inside Preseem, I'm pretty sure that's where that particular example came from. It will be actually, it will be an access point for sure. So if you go to the access points on the overview page, there's these bigger panels that have the gauges on them, and you should see that there. Now that only will be present if you have, like, as I mentioned at the beginning, there's two components of Preseem. There's the pole side where we reach out to the access network, and the inline side, which is looking at traffic, and that's traffic's where latency comes from. So if you don't see anything there, either maybe you don't have the inline component in your network, or the subscribers are not mapped properly that we know their IP addresses. And if it's a latter case, then we can help you with that. Again, the support bot or the support chat window inside the app would be the best place to start. Okay. Thank you, everybody. I hope that was useful. If you have any feedback, good, bad, or ugly, or would like to clarify things, feel free to send me an email, dan@preseem.com if you're interested. Or, of course, again, use the support box that's in the app, and the customer support team will be very happy to help you. Thank you, everyone, for your time.